this lecture will explain the rule called the definition of the conditional. So, if you have the formula P arrow Q, this can be transformed into the disjunction not P or Q. And if you think about it, it makes sense. The formula P arrow Q is true whenever the antecedent P is false or when the consequent Q is true. So basically the disjunction is just the way of explaining the truth table for the conditional. So that's why it's called the definition of the conditional. And the abbreviation for it is going to be, it's going to be def arrow. Not the most elegant of, perhaps, of abbreviations, but that's how your text does it. So we're going to do that too. And your text has two versions, a def arrow E and a def arrow I. I'm not going to worry about those details. Just def arrow is fine for both. Okay. Now, the other thing that I want to say about this is that suppose you have the formula P or Q. You might think that you could turn that into the conditional not P arrow Q by def arrow. And you can, but not in one step. So the way the rule is set up, you have to have a negation on the left disjunct of the disjunction before you can do def arrow on it. So in order to get this into a state where we could do it, we'd have to double negate the P. And then we're good to go. Then we can get not P arrow Q. That's exactly what we would get from not P or Q, because when it moves from the disjunctive form to the conditional form, you end up with one less negation on the P. Likewise, if you have the formula, another issue is if you have the formula Q or not P, you can't just go doing def arrow on it, because you need to have, the way the rule is written, you need to have the arrow, the negation on the left side. And it really, conceptually, it works much better that way. I would get confused if I tried to do it on this form. And all you have to do is do commutation on this form, and then it would be exactly this form, and you'd be good to go. So just remember to do that first if you've got some formula that's like that.